All right. So I'm just going to go over some data analysis for your bowling ball lab that you guys completed last time to kind of guide you through since I'm not going to be there to answer any questions you might have. So let's go ahead and check this out. Uh, this is your guys' data. Oh, wait, I don't want to share this. Hold on. No, I don't want to share that either. There we go. Sorry. There's the right one. All right. So let's look at this. You guys have your distances all right here. You have your times and then your average time, right? So far what we've been talking about is one-dimensional motion. We've talked about distance versus displacement graphs. So let's go ahead and do that. We know some things about it, right? If there's acceleration, it should be a smile and yada yada. We know stuff about distance and distance versus time graphs. So let's go ahead and make that. So I'll take my displacement here in meters, control, average time, and then we'll insert, where's my graph? I can't see with all this crap here. Oh, let me slide this down. Insert chart, scatter plot, and we want displacement on the Y. It goes, oh, so it's opposite. So what I'll do here is I'll do this, copy, and I'll paste it right there. So I can select this first and then do insert scatter. Okay. So if I look at this graph, you can kind of see its curve, right? Because the displacement versus time graph for something that's accelerating should smile. And that's a little bit of a smile because it is positive acceleration. All right. So what we need to do is figure out how we are going to linearize this, right? So what you need to do is look at your linearization information from there. Okay. Um, so pause the video here, go look at what you're supposed to do. So with this kind of curve, how how do you manipulate the data so that you get a straight line? All right, go ahead. All right, now that you're back, probably didn't even friggin' pause it. You're probably just waiting for me to give you the answer. I know kids. I know what you do. All right, so we need to square the time. So what we're gonna do is we're gonna go, okay, time squared. We're gonna do equals the actually let me do it. Copy this one. Sorry. I'm messing everything up here. I'm gonna copy this and put it right here. It's gonna make it for a better. It's gonna make it easier in a second here when I do this. Equals this squared. That. Let's go ahead and just drag that down. More. Sorry. All right. So we got that. We got this here, and now I'm gonna copy and paste this over here so I get the same thing. And now I'm gonna graph these two. Insert scatter plot. Got it. And there we have a straight line. Okay. So now what we want to do, we want displacements on the Y, time squared's on the X. Let's go ahead and insert a line of best fit, add trend line. It's obviously linear here. We want to set our intercept to 0, display equation on the chart. All right. Got it. Got it. Let's slide this over here. All right, we got this. So now let's think about what we knew in this experiment. Can you guys see that? If I start writing on there, let's see. So we knew that the bowling ball started from rest, so the initial equals 0. Oh yeah, you can see that. The initial equals 0. All right. We also knew that we knew some displacement, right? We knew we were recording displacement, we knew time, and we were trying to find A. All right. That's basically what we were doing. All right. So if I look at this, look at these variables, I would use this equation here. I would use delta x equals v naught t plus 1/2 at squared. Okay, that's the equation I would use, right? With all these, if I was looking for a, that's what you were looking for. If I go ahead, v naught is 0, so that kind of goes away. So I'm left with delta x equals 1/2 at squared. Is that good? Makes sense, right? That equation describes our situation we have here. Well, let me ask you this. What is on the y-axis of our graph? Y-axis is displacement, right? So isn't this y equals, and what's on the x-axis? Well, it's time squared. So this is my x-axis. So if I look at this, that means the slope has to be equal to 1/2 a. So the slope of my graph, if I look at it, is 0.24. I know that the slope in this case equals 1/2 a. I have the slope from my graph. I get 0.2448 equals 1/2 a. Well, basically to solve that, I multiply by 2. Multiply by 2, I get a equals what is that? Where's my calculator? Times 0.2448. I get 0.4896 meters per second squared. So that's how we get it graphically. Okay. Now, you're going to have to explain, you're going to have to write that all up in your data analysis part. Okay. So again, you have this video for reference, which is good. Now, let's talk about kind of the lab write-up. So abstract's pretty easy, just basically the purpose of the lab. Introduction and theory. Make sure you talk about everything that you need to complete this lab. So all the constant acceleration equations. What are those variables? You need to describe those variables that are all in those equations. You need to know displacement versus time graphs. Talk about that, what you can get from a displacement versus time graph, and just basic kinematic stuff. Okay. Materials list, you know what that materials list is. Procedure. Make sure you write a step-by-step procedure on how you get the data, just how you get the data. Then what's next? Data. So you just copy and paste the chart in, and then you put your first graph, you put your linearized graph, and that's your data. Then what I need is you to do data analysis. So you need to describe uh, constant, independent, dependent variable, why you graph what you graphed, how did you linearize, how did you get the answer kind of deal, kind of basically what I just talked you through in this video, and then conclusion error analysis. Okay. So your lab write-up, if you want corrections, is due by October 4th by midnight via email. Email it to me. Okay. Don't print it out and give it to somebody. We don't have school Friday. So also the 7th, okay. So October 7th is the due date, Monday. All right. So you have the weekend to work on it. And that's it. All right. So get it done. You can email me with any questions.